Okay, section 8.2, which is the last section before test number 2 for you. The first 3 problems are going to be talking about maximum number of real zeros, maximum number of x-intercepts, and maximum number of turning points. The maximum number of real zeros of a function is equal simply to whatever the highest exponent of the function is. The same thing, since real zeros and x-intercepts are interchangeable wording. Real zeros are your x-intercepts. That is also the maximum number of x-intercepts is also equal to the highest exponent of the function. Okay? And again, just like I just said, real zeros and x-intercepts mean the same thing. Along with another term that is interchangeable with zeros and x-intercepts would be solutions. Now, the maximum number of turning points is going to be whatever the largest exponent is minus 1. It's going to be 1 less than the highest exponent. So if the highest exponent of your function, say, is x to the 5th, that means the maximum number of turning points of that function would be 4. All right, so knowing those 3 things, your first 3 problems should be very simple. So look at number 1. For the function f of x, find the maximum number of real zeros, the maximum number of x-intercepts, and the maximum number of turning points that function can have. So real zeros simply is, again, whatever that highest exponent is. So this has a maximum number of 5 real zeros. X-intercepts will be exactly the same. Now, the maximum number of turning points is whatever the highest exponent is, but take away 1, which would just leave it to be 4. All right, number 2, same thing. Find your highest exponent. So here's the highest exponent. That term's exponent is a 6, which means that's the maximum number of real zeros and the maximum number of x-intercepts. Then take away 1 from there to get 5 to be the maximum number of turning points. Number 3, again, highest exponent. So be careful. This one, there's your highest exponent, that 5. So 5 maximum number of real zeros, 5 maximum number of x-intercepts, take away 1 to get 4 maximum number of turning points. Now, for these the last several problems in this section, it's going to give you 4 graphs. We are going to use our knowledge, first of all, of end behavior and y-intercepts to choose the correct graph. So remember, the end behavior has to do with the leading term, or in other words, the term with the highest exponent. Since this one's exponent is a 2, it is even, which means your end behavior will be the same, which means not 1 up and 1 down. Now, remember, what makes the end behavior when they're the same go up or down? What makes that happen? Whether or not this term is positive or negative. Since it is positive, that will make your end behaviors both go up. Now, your y, whatever your constant is, the number without the x, which is right here, I can already tell by the end behavior that it's going to be this one. But just to know for later on problems, if there's a number that doesn't have an x with it, that's going to be your y-intercept. That's going to tell you where this graph crosses the y-axis. So see this number right here, that -3? See how it crosses that x-axis right there at -3. All right, number 2. Same thing. Let's see. Our leading term, the highest exponent is this one. So it's odd, which means the end behavior is going to be 1 up, 1 down. So these are both down, so I know it's not that one. So here's 1 up, 1 down, 1 up, 1 down. What does a positive mean? Positive means it starts at the bottom and travels up. Okay, negative travels down. So this right here, I know it's going to be C. Because C is the one that starts at the bottom and travels up. Number 6. Again, let's look at the lead behavior. So my highest exponent is a 4, which tells me that it's even and positive. So they're both going to be going up. So I know it's not B. But look how similar these are. These are actually both going up. So now I am going to have to test my knowledge of the y-intercept, which is this number right here that doesn't have an x with it. It is telling me that this graph needs to cross through the y-axis, which is this one, at negative 18. So look at this right here. Look at what this tells you. It's telling you that the x scale, the x hash marks are going by 1s, but look at what the y hash marks are going by. They're going by 10s, which means each one of these little hash marks is going by 10s, and it needs to cross at negative 18, which is pretty close to almost to negative 20. So that one looks good, but look at where this one crosses. If those hash marks are going by 10s, that one's crossing through right at that first hash mark, which would be negative 10. This one's crossing through almost at the second hash mark, which would be leading you to the negative 18. So again, you need to watch your y scale on that problem. Number 7, my leading term. Its exponent is a 5, which is odd, which means 1 up, 1 down. Those are both up, those are both down. So it's either going to be one of these. So now let's see, is it positive or negative? This term is negative. What does a negative tell me when I am having 1 up, 1 down? It says it starts up and travels down. That goes in a negative direction because it's traveling down. You see how this one travels up, so that one would be positive. So that's why it would be C, the negative one. Number 8, same thing. Leading exponent is even, which means the end behavior will be going in the same direction, not 1 up, 1 down. Then I can just look, is this positive or negative? Since it's positive, that simply means they will both be going up, not down. Now, when yours is in factored form like this one, you can simply count these x's. So 1, 2, 3, 4. So if you FOILed this all the way out, your leading term would be x to the 4th power. If you multiplied all those parentheses together, it's not necessary. You just need to know what that leading term's exponent would be. Well, it would be x to the 4th, which is even, which means your end behavior will be the same. So that one's the same. That one's the same. This one's 1 down, 1 up. So this is down and up, so it's not that. And again, this end behavior is 1 down, 1 up. So now, look at the end behavior here. These are going down, which would be negative. This is going up, which is positive. If I multiplied all those x's together, it's going to give me a positive x to the 4th, which means your end behavior is going to need them to both go up since it is positive. All right, number 10, same thing. Let's see, I have 1. This would give me 2 x's since it's x squared. So 2, 3, 4, 5. This one will give me 2 also. So 1x here, 2 here, and 2 here. So 5 altogether. So x to the 5th, and this negative comes with it. So that's going to be, well, that's what's going to give you your end behavior, that negative x to the 5th. So, since it is an odd exponent, your end behavior will be 1 up and 1 down. So not that one. One up, one down, one up, one down, one up, one down. So these are all one up, one down. Let's see if we can narrow it down to being positive or negative, which means it needs to travel down from the left to the right, which this one does. It goes down. This one travels up, so it's not that one. But look, this one travels down too. So it's just narrowed down to these. So we need something else to help us to distinguish what to pick from these two graphs right here. Now, remember, what do these factors give you? If you turn those into zeros, those tell you where your graph touches or crosses the x-axis. So this one, if I set it equal to 0 and solved it for x, it would tell me -2. This one would tell me +3. And this one, since it's just x, it would tell me 0. This is where it needs to either touch or cross the x-axis. So on yours, you'll be able to click the little magnifying glass to zoom these to make these bigger. But I need to make sure that they are all, which one is touching the graph at +3 on the x-axis. So looking between these two, and again, let me see if I can just, so looking at that one, it looks like it's touching the x-axis at -3, 0, and +2. I need it -3, 0, and +2. So it's not that one. Look at this one. Look how it's touching the x-axis at -2, 0, and +3. So -2, 0, and +3, which would point you towards that graph. So again, just knowing the end behavior, just narrow me down to these two options. Then you would need to go back to the knowledge that we learned in the last section about the zeros and what they told me. They tell me where the graph crosses or touches the x-axis, which would be at 0, 3, and -2. So 0, 3, and -2. So that's what gave me the D answer. I'm going to need to know that knowledge on this next one too, I think. So let's see. It's going to have, so it's going to have x to the 6, right? It's got 6 x's from the 2 and the 4. So I know I need to have end behavior that is the same. So not one up, one down. So look, those are the same, both up. These are the same, both down. Here's one up, one down. So there's not that one. And those are both up. Now, there's not a negative out front like there was on the last one. So it's not going to be negative. It's going to be positive, which is good. So I would have positive x to the 6 giving me my end behavior from x2 and x4 to give me x to the 6. So I need them both, since it's positive, both need to go up, which means not that one. So once again, I've narrowed it down to these two because their end behavior both goes with this leading term test, which has an even exponent and positive. So both up. So now let's look at where it should be touching the x-axis. Where is this one going to make it touch? Since it's x minus 3, it's going to touch at positive 3. X plus 1 will make it touch at minus 1. So let's look and see where these two graphs touch. This one touches at -3 here and positive 1 there. That's opposite of what I need. I need -3 and positive 1. So let's look at this one. So look, this one crosses, there's your positive 3. There's where it touches. And there's your -1. That's where that one touches. So the positive 3 and -1 like I needed. All right, last one. This one. Here's my leading term. So since it's 10x to the third, since my leading exponent is a 3, sorry, I just knocked it out, is a 3, that means I'm going to need 1 up, 1 down. Those are both up. 1 up, 1 down, 1 up, 1 down, 1 up, 1 down. So those are all good still. 1 up, 1 down. It's positive. So what does that mean? That means I need to travel up from left to right. This one's going up. This one's going down. And this one's going up. So that's what I also know. Now this one, it's not in the factored form, so I can't tell where it's going to cross my x-axis unless I did a bunch of work. But look, it does have this. It has a number at the end that doesn't have an x, which tells me that it's going, that's my y-intercept. That's where it's going to cross the y-axis. Where does this one cross the y-axis? It's crossing it right at 0. Look where this one's crossing. Well, look, if this is 250 right here, that means each hash mark, let's see, that's 50, 100, 150, 200, 250. So each hash mark is a 50. And look, it's crossing through right in between the first and second hash marks, which is approximately 72. So that's how you know it's D. This one definitely didn't cross at 72. It's crossing it right there at the origin, which is at the 0.